morning students, myself Dr. R. Muthalagu. I am dealing with a subject called mechanics of solids. So in today's class, we are going to deal with the stress, strain, Young's modulus and how these properties affecting on the material strength. So mechanics of solids or strength of material is a branch of applied mechanics. In this especially we will deal with the force, and when the force is acting on a solid body, it is also called as rigid body. When the force is acting on a rigid body, what kind of effects it is creating on the body, how the solid body is behaving for the applied force. That kind of mechanism we will learn in this subject. So this strength of material or mechanics of solids is very, very essential in engineering field. Generally in engineering, if you see any product which you are using, maybe for example pen or paper, anything, it's all processed material. If you want to convert raw material into useful product, you should go for some manufacturing process. In that manufacturing process, we have to go for the proper selection of material. So for example, you can see here in this the raw material into useful product. So the left side is raw material, right side is a processed material. It's a finished product. In middle, how we are converting this raw material into useful product means in middle some process will be involved. That is called as manufacturing process. So when you are going to manufacturing process, you have to consider a lot of factor. In that, one of the very, very essential thing is strength of the material. Strength in the sense it depends on a lot of properties. So in that, here you can see this video. A truck is moving over the bridge. Due to heavy weight, the bridge got collapsed. The bridge might be designed for a particular stress. It is called as technically design stress or working stress. For example, the ability of the bridge is to withstand 5000 kg. The truck is 3000 kg and the weight loaded on the truck may be 3000 kg. So it's exceeding the design stress. That's why the bridge is getting collapsed. So there is a term in mechanics of solids called as factor of safety. So factor of safety is one of the important factor. Before selecting the material, before going for the analysis, we have to compulsory look after it. So factor of safety is nothing. It's a ratio between maximum stress by working stress, or it's called as ultimate stress by working stress. Working stress means nothing. The maximum capacity of the particular device, it may be a bridge or mobile phone or anything, for what load we have designed and what is the load we are applying. So that ratio should match. For example, the factor of safety for aeroplane or flight application will keep 1.25, whereas the factor of safety for car or any other automobile sector will keep 4. You imagine a car can withstand 1000 newtons maximum and we are applying 1000 newtons. So the factor of safety is a ratio, ultimate stress by working stress. Then it will be 1. FOS is 1. This perfect factor of safety is suitable for flight or some other application, but it's not suitable for automobile. There the stress should be more. For example, if I give 4000 as a ultimate stress and 1000 is a working stress, means it will match. Why we have to give more for automobile? If you see the misuse of the component, for example in automobile generally they will be designed the particular vehicle for traveling 6 to 8 members, but here you can see in this application people always will try to misuse. This is in the sense many people will travel so that it will affect the strength of the vehicle. So in such a case, if my factor of safety is perfect, ultimate stress and working stress both are equal, means compulsory the component will be failed. Whereas if you go for these are all some examples. If you go for flight application, there 200 members means only 200 members will be allowed, and the luggage also will be very defined per person, 15 kg, 20 kg, like it will be predefined. So in that case we can go for perfect stress. If it is 1000 Newton, mostly 1000 Newton only will be allowed in flight, so factor of safety will be 1. Whereas in automobile and other case there is a chance for misuse. So factor of safety is one of the important factor before going to select the material. And selection of material. So before going that, in general in engineering, any component, it may be anything, first it will be subjected to some force. If there is a body means such an object, for example mouse is a component, in that we are applying some force. So in this application mouse is a body, pen we are holding and writing, so pen is a body here. So we will apply some load like holding or pressing, so that is load. Load will always act on the body, so the body will bear the load. based on the capacity of the body, there will be a stress which will create on the body. So if I am applying more pressure over the mouse, mouse will be subjected to more stress. So if I am applying more stress on the mouse, it will be subjected to some deformation. The deformation finally will end with failure. So if I want to avoid the failure, I have to reduce the force, or my working force itself heavy means I have to change the material, means I have to change the design. So this is a way the strength of material cycle is working. So you can see some of the examples. The components are getting failed at a certain load. Here the first one is they are shooting with the bullet, it's going and hitting on the glass, and in the second application it's a Euro NCAP crash test, vehicle is going and hitting. So for this much force, how much deformation will occur, that calculation should be there. In that case, we have to select the proper material. We should analyze about a lot of properties, especially like stress, strain, deformation, and based on that we have to decide the factor of safety, and finally based on all these things we will go for the proper selection of material. So this is a general selection of material. In industry, if you go, the first process is design. After design, directly they won't go for the manufacturing. They will do a lot of analysis on the material. So while selecting the material, this many parameters will be involved. In that, especially the mechanical, electrical and thermal properties. This is one of the very important thing. In that case, in mechanical properties, our MOS will play very important role. So load. Coming to the load. Load in the sense, generally, for example, a book is there, I'm keeping and putting over my head, that is also a kind of load. So in engineering, we can define the load in a particular constraint. So there are few types of load, those kind of loads we have to consider. So in that case, here the first one you can see, the first one is tension. So the object is there and it's being held by two hands, means one force is going this side and another force is going this side. So the middle zone, this will be subjected to tension. So this is a type of force, and here in this case compression. So compression, both hand will be pressed together. So in that case the middle zone will be subjected to buckling type of effect, and this one is twisting here, and in this case shear. Shear means like a sliding effect, and in this case it is bending. So these are all the prescribed loading conditions in engineering. And if you coming to the structural application, here some other types of load will be there: live load, dead load, moving object or stationary object, wind force. If it is Europe countries, even snow load, those things also will be considered. Nowadays in Europe countries where especially war is happening, like Israel, Gaza, there they will consider blasting load also. Blasting also one of the factor they are considering while constructing the structures. So these are all load which we are considering in strength of materials. So body means, as I already told, any component where we are doing analysis on which we are applying force, what is the effect of force on this body. So those kind of things will be our mechanics of solids. So in that there are two types of bodies. One is rigid body, another one is deformable bodies. So you can see in rigid body, when we are applying the force, there will be a point between two. You can see in this object there are 2 points I kept. When I am applying the force, the distance between these 2 points is changing, means it is a deformable body. If it is not changing, means that is a rigid body. But in practically there is no rigid body based on the force. If there is an object I am applying force, the point is not moving, means the force is less. If I am increasing the force, automatically it will try to move. So practically there is no rigid body, but based on our requirement, we will assume some body as a rigid based on the magnitude of the force. So the second one is deformable body. This is best example you can see. So deformable body means like elastic nature, it will deform when we are applying the force. So for example, you can see this ball, in that I am keeping 2 dots. One is here, another one is here. Before I have applied force, the point will be stationary. So when I am applying the force, the distance between the 2 points will get very close. So when such a kind of things are happening, that will comes under deformable body. So mostly we will deal with 2 types of bodies in this subject. And the another important thing is stress. So stress is one of the very general parameter. For example, general stress are there. If you are working more time, or if you are taking some family issue or something, that will create a stress. We'll call it as a mental stress, tension, like we'll tell. But in mechanical, in especially coming to our subject, mechanics of solids, stress in the sense, when an object is there, in that object you are applying a load. For example, here is there, I'm holding here, I'm applying load. So in middle there are some material region that will try to offer some resistance to the applied force. So due to that external force, there will be internal resistance on the material. So that internal resistance will create the stress. If there is no force, no stress. When I am applying the force over the body will try to resist the force. So in a single term, if I want to say, internal resistance offered by the body for the externally applied force, that is called as stress. So mathematically, if we want to say stress is a ratio between force by area, it's a mathematical description. But in general, whenever object is there, you are applying some force, it will try to resist. So the resistance to the applied force is called as stress. In stress, there are different types. That is based on the loading direction. How we are applying the load, accordingly the stress will get vary. So here you can see some of the example. The left side one is tensile, because tension force is acting, and you can understand very well the middle one is compression, and this is an ANSYS image, how the stress is making flow. And the last image also you can see the person is beating the particular structure. Even that is also a type of load. The previous things are called as regular load, and this particular one is impact load. Impact load is nothing sudden load. So when we are applying gradually the load, that will comes under tension or compression. In that case, the distance between body and the object which is going to hit will be less, and within a short span of time the load will be applied. So that will comes under impact. So types of stress. So generally there are two types of stress. One is normal stress and another one is tangential stress. So what is the difference between these two means? For example, you can take an object. There is a tomato. So in that I can create an axis. Just imagine this is a vertical axis and this is a horizontal axis. So along this axis, if I am applying, for example, I am keeping perfect horizontal force to this will be normal to the vertical plane. Or if I am keeping perfect vertical force, that will be normal to the horizontal plane. So in that case, tension or compression will comes under normal stress. Whereas tangential stress is a type of stress that will act parallel to the cross section. For example, I am taking a knife and I am slicing this tomato, then the force will act parallel to the cross section. Okay, you might have seen when your mother is cooking in the kitchen, they will take the knife, they will do very fastly. Okay, even you can take the potato also, chips you might have eat Lays, there they will be sliced very nicely. So there, while doing the chops, the force will act parallel to the cross section. So that kind of force will comes under tangential stress. Tangential stress is also called as shear stress. So the very familiar term is shear stress. Whereas normal will comes under tension and compression. So you can see some of the examples for normal stress. Again, the mathematical description is force by area. P is the applied force and A is the cross-sectional area of the particular object where the force is acting. So the best example, as I already told, tensile is one of the best example. Here when we are applying the force in the opposite direction, the middle zone is getting deformation slowly. After certain level it is getting break. So this zone is called as necking zone. So tensile stress will act when two forces acting in the opposite direction. And this is the best example for compressive stress. Line of action will be same, but the direction of the force in tensile it will be by opposite, and here it will be in the same direction, means towards it will try to meet. When we are applying the compressive force like that, the middle zone will get damaged. You can see in tomato, if I hold and if I press like this, you can see here crack will come. Very familiar example, you might have tried in the childhood. So when we are pressing this middle zone here and here, it will try to deform. So that effect is called as technically buckling. So this zone where you are meeting, this particular zone is called as buckling. Again, here also, if you want to calculate the compressive stress, the mathematical description is force by area only. But here the direction of the force is different. Accordingly, magnitude will get vary and the effect on the body also will get vary. And this is a tangential stress. Tangential stress is nothing shear stress, as I already told. So here is a loading direction. If you see, that will be tangent to the cross section, or it is also called as it's a parallel to the cross section. So if load is acting parallel to the cross section, then shear stress will occur. So you can see some of the examples for the shear stress. When we are doing cutting, the load acting is this zone. This will act parallel to the cross section. So automatically tangential stress will occur. And when we are trying to sharp the tools like knife and other thing, also such a kind of effect will happen. You can see in automobile, when especially we are trying to apply the brake, the tire will be subjected to shear force. And even in fluid mechanics, when the flood is happening, or even in the proper pipe structure, when fluid is flowing also, shear is one of the important factor we have to consider. And even in landslides also, you can see. So a force which is acting parallel to the cross section, then it will comes under shear force. And because of the shear force, the stress will occur, that is called as shear stress. Then coming to the strain. So strain is one of the interesting factor. Always when we are applying a load, material will be subjected to stress. Because of stress, some deformation will occur compulsory. Again, it's based on the material nature. So if I am applying a force, material got damaged. So before applying force, there will be some dimension, how much length, how much width. After applied force, the deformation will create some change in the dimension. So the ratio between change in dimension divided by original dimension is called as strain. So here they have mentioned, so change in dimension. Some people will tell change in length by original length. That is not correct. Actually, in every case, we want to measure only length. So change in dimension divided by original dimensions. So it may be length or breadth or volume, anything. And here the important thing, strain is a dimensionless, because change in dimension also, if you are considering only length, here also millimeter, original dimensions also will comes in millimeter. So always there won't be any unit. Whereas if it is stress, force by area, the unit for the force maybe Newton, kilonewton or meganewton, we'll keep in Newton, and area meter square, centimeter square or millimeter square. So Newton per meter square is a common unit we will follow for calculating the stress. And again, in strain also, there are some types of strain that comes under longitudinal strain, volumetric strain, shearing strain. So again, longitudinal strain means we will consider about the change in length by original length. Volumetric means change in volume by original volume. And shear strain means again that change in shear by actually original cross section. Those things we will consider. You can see. So longitudinal means you know very well. For example, if a pen is there, here linear most axis is there, so this will be the longitudinal direction for me, and this will be the transverse. If I change like this will be the longitudinal and this will be the transverse. So the linear most dimension will be considered as longitudinal direction. And similarly in volume, change in volume by original volume will comes under factor. For example, you have a balloon. When you are blowing the balloon, the volume of the balloon will get vary based on the pressure of the air. So change in volume will occur. But originally the balloon might have some volume. So if the change in volume is 150 and the original volume is 50, since it is volume, unit will be mm cube, 150 by 50. So the strain will be 3. There won't be any unit because mm cube by mm cube will be cancelled. So the volumetric strain will be 3. So like that we will calculate the strain. And the next interesting thing is modulus of elasticity. Always when we are selecting the material, the modulus of elasticity, it is called also as Young's modulus. So the Young's modulus, modulus of elasticity, both are same meaning only. Mathematically, if I want to say, it's a ratio between stress and strain. So far we discussed about stress and then we discussed about strain. Now I am telling about Young's modulus or modulus of elasticity. So it will be mentioned denoted by the letter E. So stress by strain. So always some stress will occur. For example, because of the applied load 250 Newton per mm square stress is happening, and strain because of that, for example 5 mm getting varied. So we will calculate and we'll get some value. So in that manner we will calculate. So whenever modulus of elasticity of a material is large, it means the larger stress will produce only a small strain. So the deformation will be less. So for example, steel, normal construction steel, if you see, the modulus of elasticity is 210 gigapascal. Okay, but whereas if you go for some other material, the modulus of elasticity will be less. So based on the application we can select. So it's not like modulus of elasticity should be always high or always low. Based on our requirement we will do. So when we are going as per the stress strain curve, especially Hooke's law, when the material is loaded within an elastic limit, stress will be directly proportional to strain. So that concept only representing the modulus of elasticity. And again, the modulus of elasticity depends on 2-3 factors. One is bulk modulus. Bulk modulus is depends on the normal stress by volumetric strain. When we are doing some volumetric analysis, for example, in bike, petrol tank is there. Petrol tank is one of the very good example. Fuel tank is one of the very good example for volumetric design. In that, if you want to consider the elasticity factor, you have to go for normal stress versus volumetric strain. And modulus of rigidity is best example for shear stress by shear strain. Whereas Young's modulus is normal stress divided by longitudinal strain. So these are all the important factors we need to consider compulsory before selecting the material. And here one of the simple problem is there for an example. So a rod of 150 mm long, they have given some value, long means length, and 20 mm diameter, D they have given, is subjected to an axial pull of 20 kilonewton. Pull means it's nothing, it's a load. Means we can keep the letter P or F, anything. So P equal to 20 kilonewton. If the modulus of elasticity, just now we discussed, it's a ratio between stress and strain. The modulus of elasticity of the material is 2 into 10 power 5 Newton per mm square. These are all the data they are given. Determine the stress, strain, elongation of the rod they are asking. So far we have discussed stress means nothing. It's a ratio between force by area. And what we discussed for strain, when we are applying, before applying some original dimension will be there. When we are applying load, change in dimension will occur. So strain means change in dimension divided by original dimension. And the elongation means, again we can consider the change in dimension, how much it got elongated. It may be, if it is compression load, the dimension will get reduced. If it is tensile load, the dimension will get increased. So accordingly, if you see, now coming to the stress, separately I am writing here, stress equal to force by area. So here the force value which we have got here is 20 kilonewton. So 20 into 10 power 3 newtons divided by area equal to, it's actually rod, and the rod they have given a diameter of 20 mm. So pi by 4 into d square is a formula for calculating the area of the cylinder. So here pi by 4 into 20 square. If I keep the stress value, we can get 63.66. Unit will be Newton per mm square. Newton is for force, mm square is for area. So Newton per mm square we have given. Okay, so this is the way to calculate the stress. Now coming to the strain. So strain actually change in dimension. Here the dimension will be length. So change in length by original length I am keeping. So I got the original length, but I don't know the change in length. That only I have to find. So here how we can execute this problem further means, there is a property called Young's modulus. Already we discussed Young's modulus is the ratio between stress and strain. So here I know the Young's modulus value, that is 2 into 10 power 5. And stress value I got 63.66 divided by strain. So the symbol for strain is this. So strain value will be 63.66 divided by 2 into 10 power 5. So if I derived this, the strain value will be 0.00 0.3183 and strain won't have any unit. So here I have calculated the strain. So stress I got, strain I got, two things over. Now elongation. When you are coming to the elongation, already I mentioned here, strain is the change in length by original length. So here I have the strain value. So this value I can take and I can apply here. So 0.003183 is a strain equal to change in length divided by original length, that is 150 mm given in the given data. So from this I can calculate the change in length. So the change in length, it will be 0.047 mm. So for example, if you assume this is a rod, so when you are applying a load of particular, here they mention pull, so kind of tensile load 20 kilonewton, how much it will get elongate. So finally we found 0.47 mm it will get elongate. So 0.47 mm, if it is a considerable elongation, the design is safe. For example, the material 0.47 is very dangerous, it will fail means the design itself failure. Then what we can do, either I can change the material, because I can't change the load. For example, if a car means minimum I have to design for 6 members has to travel. If it is a bike means at least 2 members is actual design, but generally people will go for triples also. So I have to consider 3 members weight. So in this case, I can't change the load. Then next way, I have to go for the different material. If plastic is not working, I have to go for some other metal without compromising the weight. Okay, without compromising the strength. You can go for any material, but mechanically if it is not safe, the design will be failure. So how to select a material? There are so many things. In that, one of the important thing is stress strain curve. So far we discussed about stress, strain, Young's modulus, and we have seen a small problem also. But generally, if you want to propose a material for a specific application, or in real-time materials research laboratory, people will involve with the innovation of different materials. For example, I am a scientist, I am bringing with a material, you are my superior, I am showing this material will be very much superior for your application means, they won't believe directly. They will take that material, they will go for different testing, and this will be the complete graphical representation of a particular material. The failure rate, how it will occur. For example, before releasing the movie, they will release the teaser and trailer, some overview they will give. Like that, before taking the material directly to the application, we'll go for the testing and we will get the idea based on the stress strain curve. So here in the stress strain curve, you can see when the material is loaded here and here, stress value will get increase. And here is a Young's modulus, ratio between stress and strain within elastic limit. So in every material, there will be a yield strength, there will be a ultimate strength, and there will be a breaking strength. So yield strength means before elastic limit. In this zone, material if loaded also, like elasticity, it will load, it will come back. But once if it is crossed that elastic limit, the deformation will be plastic deformation. So this region called as plastic zone, this will be elastic zone. So what is the value? Here in stress, when you are going for real-time testing, there will be some values. For example, 250 megapascal is the yield strength. Ultimate strength, if you go, if it is 400 MPa, it will reflect here. And after ultimate, it will start to reduce. So mostly we will consider ultimate strength as a maximum one, and yield will be the design one. Breaking strength is to find after loading this much, it will start to deform, and at a certain point, it will fracture. So ultimate strength is a major concern, but most of the cases, they will keep the working stress as a yield strength, because once the material crossed that elastic limit, at any time it may fail. So for operator, for the consumer, if I tell ultimate stress as the maximum working stress, they will try to misuse more. Okay, so for safer side, always we can reveal yield strength as a maximum one. So now here I mentioned 250 megapascal is a yield strength and 400 megapascal is the ultimate strength. For a particular application, if yield strength I required is 270 megapascal, the proposed material having only 250 megapascal, then this material will not work out. Whereas in another material, here we are getting 300 megapascal, where means in yield strength I am getting 300 MPa. then that material is okay. We can take it for the further study. So in that way, they will select the material. And here also, when the material is loaded, automatically the curve will get increased after proportional limit, elastic limit, after elastic, yield strength, ultimate strength, and breaking strength. And again, the material behavior is based on the material nature. For example, the stress strain curve, if it is a brittle material, brittle means directly failure will occur without any elastic deformation. You can see the brittle nature. For brittle material, when load is increasing, the curve will increase. After a certain point, suddenly breaking will come. So the best example for brittle material is glass. If you take the glass, if you try to bend, it won't bend. But if you apply some load without any indication, immediately it will fail. So that means load will increase, suddenly it will fail. So that kind of stress strain curve will come. So brittle material has some advantage and disadvantage. Based on the application, we can take it. Whereas ductile behavior, ductile means it's a kind of elasticity. We can bend the material as per our comfortable. So for ductile material, the stress will go for different region, proportional limit, elastic limit, yield, after that ultimate, after that breaking point. So elasticity is one of the important factor which we can't avoid in mechanics of solids. So the property, simple definition you might know very well. So for example, a thread is there, I am holding one edge and another edge I am trying to push, means it will bear the load, but it won't withstand. After certain level, it will try to break. Whereas you can see a rubber is there. If I apply load, it will take the load. When I release, it will come back to its original position. So the ability of the material to gain the energy and release that energy when we are releasing the load, that kind of nature is called as elasticity. So elasticity, without elasticity, some application we can't proceed. For example, I can show few of the examples here. So this is one of the best example, leaf spring. In heavy automobile vehicles like a truck, bus, they'll go for leaf spring. If it is normal one, they will go for compression spring. And even this example also you can see. And this kind of springs will save us from the shock. It's called a shock absorber or suspension system. So we will have the elasticity nature. If not, we can't get the comfortable journey in the bus or car, anything. So forget about the journey and other thing. Here the technical thing is, you can see when we are applying a load, it will be able to take the load and it will deform. When we are releasing the load, automatically it will come back to its original position. So this is called as elasticity. So because of that only, we can get a lot of benefit like suspension and safety systems in lift. So many examples we can see. And so far we have discussed about stress, strain, Young's modulus, modulus of elasticity, elasticity nature, stress strain curve. So these are all the syllabus content. If you want to go further beyond the syllabus, what is the real-time application of this subject, MOS, why this is that much important, like if you want to go through. In industrial advancement, nowadays in mechanical industry, simulation is CAE, it is called as CAE. You know, CAD is computer aided design, CAE is computer aided engineering. It is analysis and simulation. So there are so many softwares for that. Altair, especially the most familiar one is ANSYS. In ANSYS, Workbench will be there. In ANSYS Workbench, you can do a lot of simulation. Okay. So if you want to perform in future, if you go to industry, compulsory this MOS knowledge is very, very important. And this is advancement. When you are learning stress, strain and all the things in software, for example, this is a structure. For this structure, you want to know about the stress value. At what stress it will fail. Then you have to know about the material, which material is suitable, what is the Young's modulus, what is the ultimate strength of the raw material, and when we are keeping the structure, that properties will apply in the software and it will produce the result. We can get the result of stress, strain and other deformation, so many things. And here you can see the disc brake analysis. So in that, lot of holes are there. The reason for the holes to reduce the weight as well as to do heat dissipation. If we keep more geometry, the strength of the disc will get reduced. So how to do? So material optimization. So which material will be suitable? Again, it will come to MOS only. So here best example, automobile application. In this, mostly this particular zone is called as in the car safety zone, and this one crumble zone. So in safety zone, the deformation will be less. Why? Because passengers will be sitting in here only. So whatever damage may occur to the vehicle, the passenger who is sitting inside, that should be safe. So how to change that? Again, we can go for the change of factor of safety, which we have seen in the third and fourth slide. So this is a way in real time industries are running, and to perform in this, we need to have the good knowledge in mechanics of solid subjects. So these are all the fundamentals we have seen today: stress, strain, and we had seen a problem also. In upcoming classes, we'll discuss about other parameters also, like shear force, principal plane, principal stress, bending stress, and then torsion. Those factors also we can discuss. Okay. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.